NCBM 0324, Section 1.3, Slope, Formula, and Graphing Linear Equations in Slope-Intercept Form, Part 1. So let's go more into depth about those linear equations. We solved linear equations in one variable, but what does it mean to be a linear equation? Well, linear equations have something unique about them, a characteristic that you may have heard about before called slope. So what is the definition of slope? We're going to say the slope of a line that passes through 2 points, right? And a line has no curve to it. We're going to say a line is just straightforward. But it passes through 2 points is defined. So what is slope again? It's defined as the change in y divided by the change in x, more commonly known as rise over run. And in fact, that slope equal to rise over run is going to be a really nice way of interpreting and graphing what it means to have a slope. So we're going to say at the rise part here, if it's positive, then that means we're going to move up on the graph. And if the rise is a negative, we're going to move down. So up is positive, down is negative. If the run, the bottom, remember run is in the x direction. If it's a positive, a plus, we're going to move to the right. And if it's a negative, if there's a negative in the denominator, we're going to move to the left. So this rise part is the y direction that we're moving up or down. The run, the bottom, is the left or right movement. So with that action of up and down, left and right, that's the rise and run. And the 2 points that we know this line passes through, we have a nice formula. So the formula to find the slope of a linear equation, this slope value is equal to y2 minus y1 all over x2 minus x1, where these y and x values are coming from the 2 points. So if I have the first point is x1 comma y1, my next point is x2 comma y2, then I can find the slope by taking these numbers and plugging them into this formula. Let's try it out. Example 1. Given a graph of a linear equation, so looking at the graph, we have a nice line. Remember, there's no curve to these linears. We want to find the slope graphically, so interpreting with rise over run, and algebraically, which means to use the formula. So let's take a look at our graph a little more closely. Again, it's a line, no curves to it. We can see it's going upwards, right? If I look at it from left to right, it's going upwards here. So let's talk about the slope of this graphically first. Now, graphically, we're going to have to somehow measure the rise part and the run part. And again, we're calculating the slope from 2 points. So to even do this graphically, I need to identify 2 points and measure that rise and that run. So looking at my graph, I want to pick 2 points that match exactly to my crosshairs on my XY plane. Right? This is our Cartesian plane. It's what we graph on in our class. So identify points and pick points that it's going to be easy to figure out the coordinates, the x and the y. You don't want to pick something like, let's say this point here, because I can't measure exactly what is the x value, what is the y value. I want to pick something a little easier to handle. And in fact, I see one down here that's pretty nice because it's on my y-axis. So I can say here, I'm going to pick the ordered pair 0, negative 2. 0 in the x direction, negative 2 in the y direction there. So there's my ordered pair 0, negative 2. Now I want a second point that's going to be easy to measure off from this point here. Again, I don't want to pick anything in the middle. I don't even want to pick this one because I don't know exactly the decimal approximation of it, right? In fact, it would only be an approximation, and I want this to be exact. So I'm going to look, and it seems like this point here might be a good match. And that ordered pair, let's see, the x goes 2 and the y goes 1. That looks to be 2, 1. And then I'm going to make my measurement. My rise is the up and down movement, up and down. My run is left and right. So from this ordered pair, I'm going to see how many units up I'm going to have to reach in order to get to that second point. So from here to here, it looks to be like 3 units up. Then I'm going to look to see how far to the right or left, depending on the direction of my graph, but in this case it's right. How am I going to have to move to make it to that point? And that looks to be 2 to the right. So in the graphical sense, for my slope, my rise, since it's a 3 up, it's a positive 3. And my run was 2 to the right, that means it's a positive 2 to the right. And there's my slope. So graphically, we're looking for those movements. How far in the x direction? That's the run. How far in the y direction? That's my rise, right? Rise over the run. Now, it won't always be that nice to identify those points, right? Sometimes we need to use the formula. That's why it's nice that we have the formula available to us. So let's see if we get the same answer algebraically. So from my ordered pairs that I picked, so I'm going to have here 2, 1, 0, -2. If you need it, just because there's a lot of numbers floating around, label your x1, y1, and your x2, y2. So when you go to use the formula, you know where to plug in the numbers. So formula is y2 minus y1 all over x2 minus x1. So my y2 is a -2 minus my y1 is a positive 1 divided by, let's see now, the bottoms are the x values, so 0 minus 2. And I have a -2 up top minus 1. Well, that's -3. 0 minus 2 is -2. It may look like we have a different number than what we had graphically, but what is a negative divided by a negative? We can write that as a positive. So that slope is the same answer we had graphically, right? So our ordered pairs worked out nicely. So graphically, rise over run, it's a good interpretation. Even algebraically, we can